Hi, welcome back to another talk. This time we have Secure Boot, Security, Tooling, and the Future. And the speaker is Steve. Let's welcome Steve.
Hey everyone, I hope you're having a good day. You may remember me from previous talks about Secure Boot and all kinds of other stuff. I hope this is interesting. There's a lot of stuff. It might be quite dry. Please shout at me if I'm being too boring. So, I'm going to talk about what Secure Boot is for. I'm going to talk about, is it worthwhile? A whole bunch of stuff about keys. This is where it's going to get boring. Sorry. Bits and pieces about the packaging and the tools, and some stuff coming. I am not good at predicting the future. I'm not going to tell you today's lottery numbers or anything, but I'll see what I can do. So, who knows what UEFI is? Who actually knows what UEFI is? So, UEFI fundamentally is the Unified Extensible Firmware Interface. That's what it is. It's a set of interfaces. What most people think of when they see UEFI is particular implementations of that interface. So EDK2 was created by Intel, started for Itanium as a new firmware, which was much better than BIOS. There are other implementations out there too, which can look incredibly different under the hood. The whole point about UEFI is it's a clean set of specified APIs, much richer than what you got with BIOS. They fall basically into two camps. There are APIs that must be provided at boot time, which are called boot services. You'll never guess why. And then later on, there is a more optional set of services that are applied at runtime. So once you've loaded something, say your Linux kernel to be the obvious choice, there are calls it can make back to firmware, and if they're provided, it can do useful stuff. Exit boot services is a critical one-time call from boot services that changes the world. Once you've called exit boot services, you cannot use things that are not in one-time services. I hope that's clear. So, what's Secure Boot? Fundamentally, it's a way to protect against persistent boot time malware. People know what I mean by that, I hope. If you remember the old boot sector viruses, where you could have a bit of malware that could install itself onto your system and it would be there forever in the boot sector, this is what this is to guard against. Using Secure Boot, every bit of software you load and execute, is verified by signatures. Each step in the boot chain verifies the next. It just then becomes a problem of key management, and we know that's easy, surely. You can use this as a base for lots and lots of other security stuff if you want. Measured boot is where you can actually track every single thing that runs, and you can compare checksums, you can compare to make sure that nothing has changed since last time you verified your system, and stop if anything did. That's wonderful, not for everybody. If you want to have a completely locked down kiosk system where nothing can run that you haven't verified, that's available too. But you need something to bootstrap it, and this is that step. There's lots of other things here too. Go and look on the internet. I'm not going to talk through all of that. So, what is Secure Boot not? It's not a way to lock you out of your machine. You can, on almost every machine out there, enroll your own keys, which lets you have control over the stuff that runs. Or you can turn off Secure Boot if you want, again, on almost every machine out there. You don't have to do this. This is just to stop the spread of malware for most people. It is not a way to stop people using Linux and other free software. Microsoft are not all that evil here. I know some people think they are. The point here is to add security. Both sides of the discussion want this. So, is Secure Boot worthwhile? And the answer is yes, for most people. Persistent boot time malware is a real problem. There are bad people out there who would still like to install crap on your computer and take control of it at a level that you can't tell. There is a flip side. It makes some things harder. Hibernation, as in suspend to disk, is really difficult. There are people working on a solution for this. We don't have it in Debian yet. Loading third-party kernel modules becomes a bit of a pain. You've got to sign those. If you don't sign them, the kernel won't load them. Kexec, similar. You have to have signature on every single binary, on every program that you want to run at this level, so you will need to sign the next kernel that you load. It all gets a bit awkward. The thing that you have to turn off here is direct access to memory and I/O ports. If that's available, then there's no point signing. You get no security if you can just change things underneath. Given all that, for most people, and I know I'm in a room full of free software enthusiasts who like getting low-level access to their systems, for most people, this is a good thing. So there's a whole bunch of misunderstandings that I've heard over the last few years, and I wish people would actually read about the topic before spouting rubbish. So we've already had the Secure Boot is just designed to lock you into Windows. It's patently false. Microsoft work with us. Microsoft have their own Linux distribution that goes through the same process here. They're not locking you into Windows. I've heard people claim that Secure Boot adds more vulnerabilities. It really doesn't. The argument here was that, oh my God, suddenly Grub has CVEs that are all caused by Secure Boot. No, we now have CVEs to track the places where Grub was vulnerable and could leave a route around Secure Boot. We fixed those. When we find more, we fix those. That's all. I've heard somebody say in Debian IRC channels, Secure Boot doesn't work if you use testing. No, it really does. Believe me, I've done it every day. And then Secure Boot doesn't protect the average user. That's exactly the user that it's for. So, fine. There's probably other stuff you hear too. It gets boring sometimes. So, Secure Boot is fundamentally an issue about key management. I'm sorry, this is the boring bit. We all know about managing keys, and we know that just keeping track of things is hard. Microsoft keys are included with most Intel or AMD, x86 PCs. They're available on a lot of the bigger ARM64 machines. This all comes down to the logistics of somebody needs to be a CA. Nobody wants to run a CA. Talk to any of the companies involved, including people at Microsoft. It's an absolute pain in the ass. It really is. But it's necessary if you're going to follow a chain of keys. We're going to end up with more architectures too. So the UEFI setup for Secure Boot specifies 4 key rings. There is the platform key, which is the one key that is embedded in firmware by your machine vendor. So, for example, I have a Lenovo ThinkPad. The platform key on this is a Lenovo key. The key exchange key is then the next level up from that. It is signed by, the keys in that must be signed by the platform key. And those are an intermediate step. The one that really matters, the one that we care about for most of our stuff, is what we call the DB keyring, which is where we put the authenticated variable database. The acronyms don't really work anymore, and I don't know why. The last one that is in the traditional setup is the revocation database, the DBX. That's where you put things that you don't want to work anymore. And I'll come to that shortly. Later, we get a fifth keyring, which is specific to how we do secure boot on Linux, which is called mock. I will explain when we get there. Now, on almost every machine out there doing secure boot, you can modify all of these lists. If you want to take control of your system, you can turn off secure boot entirely, turn it into setup mode, enroll your own platform key, and everything you get from then onwards is yours. It is not easy, I won't promise it, I won't pretend it is, but you can control everything on your system. So the DB keys are the bits that really matter. These are the things that are used for signing the bits that you run. There were two root CA keys initially defined, and if you have a look on any of your systems, you'll probably find these. There's the Windows production PCA key. I'm going to say nothing more, it's boring, nobody here wants Windows. The one that really does matter, and the one that's caused so much pain over the last few years, is the third-party UEFI CA, which expired last month. Has anybody here had a problem with their computer booting in Secure Boot since that expiry? Awesome. If anybody had said yes, I was going to cry. Microsoft were quite late in pushing out the new CA keys that they needed. We've got a new Windows CA, we've got a new Option WOM CA, and a new UEFI CA that were all created in 2023. They started rolling them out into hardware through hardware vendors. Last year, they started signing things with them also late last year, which was very, very tight towards the expiry date. I should point out that the Windows key, the old Windows key, was used for just signing with the Windows bootloader and nothing else. The third-party UEFI CA was used for signing Shim, which I'll come to shortly. That's what we use. It was also used for signing other random tools that people have shipped, say disk encryption tools and all kinds of recovery software, whatever. And the one that really confused people, it's also the key that is used to sign, or the key chain that is used to sign the option WOMs in your PC. So most of the firmware blobs are signed because otherwise they could have crap in them that you don't want. And the vendors have to send that firmware to Microsoft to get it approved and signed. But they all went into one keyring. We've now split that going forward, and there is a separate option WOM CA. There were arguments about whether or not there should have been more of a split, but this is the one that Microsoft went with. So the key thing is, and I'm glad that no one saw this, key expiry should not break boot. The spec for UEFI Secure Boot says that, yes, here is a CA, it has an expiry date on it, but at boot time, you can't trust your clock. You don't know if your clock has been fiddled with by the user, you don't know if the battery's died, you cannot reliably get current date and time. So part of the spec is that the UEFI firmware should never check an expiry date. So it doesn't matter that this key has died, they will continue to work. What we do have a problem with is we can no longer use those CAs, those keychains, to sign future binaries. And that's where the fun starts. I'll come back to that. The other piece that you should be getting regularly is DBX updates. Remember I said this is for revocation. So these are for security. You can either block older keys, so you can block off an entire chain, or you can block older binaries by hash. Keep applying DBX updates. If your system tells you that there is a DBX update, apply them just the same way you'd apply any other security update. All of those people who keep saying, oh, Secure Boot isn't secure because of these workarounds, because of these broken bits of software, this is how you stop those working. If you're not doing this, then you're asking for people to own your system. If they manage to get in, that's kind of pointless. So the best way of updating and keeping on top of the updates for your firmware, for your secure boot keys, is to use FWPD. Does everybody here have it installed? No? If you don't, please do. I appreciate it's awkward on servers because you may not have the desktops installed and whatever. Definitely go and install it if you can, because this makes a lot of this easy. It will go and check periodically for signed updates for the CAs and for other bits and pieces of software, and will offer to apply them. There's a list of commands here. If you're running a current desktop environment, like GNOME or KDE or whatever, it should automatically be doing some of this for you in the background. If you're not, there are some simple tools here. If you want it to manage your CAs, then you will need to make sure that you're up to date in either Trixie or Bookworm. The most recent point release, literally a week ago, we pushed in a recent enough version of FWPD that it should work. There was an issue in Bookworm that we're going to fix shortly, don't panic. But these should find updates and they should apply them for you. If you want to validate that you have the latest DB keys, make sure you have the latest CAs installed, run this mock-util command, mock-util --db, dumps the contents of your DB. It's that simple. There are other ways of doing it too. If you were going to apply vendor firmware updates, a BIOS update in old terminology, that will often come with updated keys. But of course, that assumes that your computer is still within support, or that your vendor is still providing updates. That's not guaranteed for everybody. If your machine is more than 4 or 5 years old, you may not be getting those updates anymore. But LVFS should do the right thing for you. You can apply them by hand using EFI-var. It's scary. If you get this wrong, you may break your computer, so be very, very careful if you do, and I'm not providing any warranties. Please don't blame me. If you do have a system that's dual booting with Windows, it will also try and go and get these updates. Because, again, Microsoft, while we may disagree with them on many fronts, they also want to make sure that the key updates are rolled out to everybody for obvious reasons. The last thing about what FWPD do and Windows do is they have safety checks. Nobody wants to break your system by installing keyring updates that mean it won't boot next time. Unhappy users makes for unhappy people having to support those users. We all know that, yeah? So, I mentioned about the key enrollment key. The other issue that we have is that, well, we need to update that too. As I said earlier, the platform key signs the key enrollment keys. The key enrollment keys sign the DB and the DBX. Oh, the existing KEC expired as well last month. So if you want it, for now, it's all fine. Everybody has already done the latest round of DB keys. We already have the new CAs rolled out. But the next round won't happen unless you also have an updated KEC. FWPD will do this for you. It should do. There's a few people reporting issues. We have bugs to track down. Don't worry about it. It'll all be sorted. But when your system says it wants to apply a KEC update, don't panic. It's the right thing. Everything should be signed in cascading order all the way from your hardware vendor, and it should all be good. You already trust them for everything else in the firmware. This is no different. So, what does this tell us? Key management is hard. We know it's hard, but it's necessary. We know that the CA rollover was late. I know the people at Microsoft who were responsible for rolling this out, and they will privately and probably publicly admit they should have got to this much earlier. They could have done a better job, but it had to happen. We know that there will be more key rollovers coming. So this is part of what you do when you generate a public key system like this, is you have to account for key rollover in your design. Don't panic when things change. One of the benefits of talking to Microsoft, and we've done this a lot recently, is we have all in the various distros checked that multiple signatures should work. So the existing Shim binaries that are now in Bookworm and Trixie and Forky are all signed with both the old CA keys and the new CA keys. They should all just work. We have a vanishingly small set of reports of machines where they don't, and we're providing support to those people. Fundamentally, buggy firmware is a problem for all of us. We've had this before. So, Shim is the first important piece of the software that we provide to make Secure Boot work in the Linux world. James Bottomley and Matthew Garrett and a whole bunch of other people have worked on this over the years. This Shim is the smallest, most reviewable bit of primary bootloader software that you'll ever see. As a habit, as a security check, I personally review in the Debian package every change that goes into Shim, and I know other people do this too. This is the point of this. We want it to be trustable, we want it to be safe. For legal reasons, it is permissively licensed. Microsoft will not sign GPL binaries, particularly GPL3, because of the worries about legal issues. So Shim is designed to be buildable and distributable in binary form by anyone without having to worry about license implications. It's, for those of us who really like the free software movement and we want to use GPL by default, this is one of those compromises that we have to accept. Microsoft will sign shims for people, and believe me, they sign a lot of shims, but after review, I'll come to that next. What Shim allows you to do is embed your own keys so you have a new root of trust. So the Debian shims include a Debian Secure Boot CA, and then that is used as the new root of trust for signing multiple more things, and this is how the whole system works. It also, Shim adds another trusted key ring called the machine owner key. Hands up here who has heard of this before? Have you ever had to fight with it? Yeah, a number of you. This is really useful. This allows you to specifically add extra keys into the trusted key ring that you control. So obviously you trust Debian because we're all cool people and you'd never not trust us, but this lets you add your own things too. It's your machine, why shouldn't you? This is particularly useful if you're using DKMS. So if you're loading if you're loading locally built binaries, we all know about the NVIDIA drivers, for example, here. This is how to make those work flawlessly with Secure Boot. Follow the procedures, it's all documented, and it should just work. So, Shim Review is an interesting place. You know those of us who keep on volunteering for too many things and can't walk away and there's always more things to do? This was my example of that. There's a team of cross-distro volunteers who are responsible for reviewing all of the Shim builds that are submitted to Microsoft for signing. Microsoft admitted to us a few years ago that they didn't know what a Shim build should look like. You know, they were signing things, they were hoping they were right, but then they said, no, what we actually want is a bunch of the Shim developers and maintainers to actually look at these things, to develop a process for checking everything about a shim and then saying yes or no. For my sins, I ended up volunteering to help join that team, and now I'm running it. Oh my God, I'm a moron sometimes. The key thing about this team is we are supporting all of the Shim users, so that's the other distros, who have a free and open source boot chain. We have had other people come along, companies who want to use Shim just to then load their proprietary system. Why should we be providing support for those people in our volunteer time? And the answer is, we don't. So what we do is we check over the Shim builds for security. This is the point. We review the boot chain. So Shim, Grub, now systemd boot, I should have put that here as well, Linux, FRUPD, everything that a particular vendor comes to us with, we want to validate that they're doing the right thing. And we don't expect people to be trying to work around us, but we do expect to find the odd mistake. And hell, we've made mistakes in Debian too. Other people in reviewing these submissions get to check that you've done the right thing, to make sure that we don't end up with one person missing that bug. We have multiple reviewers reviewing each of these submissions. This is good stuff. We validate the identity of the people submitting. We have a lot of questions checking that if you're using Grub, that you have all of the updates applied. If you're using Linux, which of course we are, you have all of the appropriate secure boot fixes applied there too. And we have a lot of sanity checks just to check that you actually understand what you're doing. It's an involved process, but it's necessary because we want to make sure that holes in your secure boot chain don't happen. So after that piece, and I've been through that multiple times for Debian, asking other people in my team there to review it, we then get signed binaries back from Microsoft. We have a Shim signed package in Debian, which is all about the packaging for those signed Shims. It's the end of a long pipeline. So it can take, it has taken in the past literally months from a new Shim release coming out to me doing the packaging, to me doing a build and a submission. It can take months before it all comes back and we eventually push those builds into a new version of Shim signed. The most recent version that we have, as I mentioned earlier, are dual signed. They're signed with both of the UEFI CAs. There was this golden window between October last year and the end of June this year, where every submission sent to Microsoft, they would send back individually signed copies of those Shims, one with the old CA, one with the new CA, and then we could ship them as we liked. Instead, what we do in Debian, and most of the other distros are doing this too, is we verify, first of all, that the binaries we've been given back are exactly the binaries that we submitted, just with a signature attached. Go and have a look at the source package here if you want to. We absolutely validate to make sure that's the case, and then we combine the signatures. The tools that we have, and I'm coming to that shortly, will let you do that, and then you have a Shim build, a single Shim build that will work on any system that has either of those keys involved. That's easy. Except the next Shim build I do, this isn't going to happen because Microsoft can't sign with the old CA, so the future ones won't be dual signed, they'll just have the new CA. So, can anybody see what's going to happen if you have an old system that doesn't have that new CA installed? We now have a pre-inst check in Shim signed, and it needs to be pre-inst so it fails appropriately early before it can break your system, that will validate that the Shim it is about to install has been signed with a key that your system knows. Nobody, believe me, nobody wants your random security update that potentially unattended upgrades has just installed. We do not want that to cause your computer not to boot next time, because that's just angst. It's horrible for everybody. So we explicitly check that. If you are seeing your computer complain about this right now, and we've had a few bugs, please report it immediately so we can help you before it becomes too late. So I've mentioned that there are cross-distro discussions. Shim Review is an example here. We also have a regular discussion, or regular discussions, both online and, thank you, we have online discussions all the time between the distro maintainers for Shim and Grub and Frupti across all of the distros, and we have a regular call as well that includes Microsoft people. So we get to talk about the issues, and this is how I know that the Microsoft people are not trying to screw us over. They want this all to work too, because again, they don't like being shouted at either. It's good stuff. It keeps us busy. So we do get some problems that people have had with Secure Boot. It is not perfect. So one of the problems, especially with older machines, is you would have limited variable storage space. If you go back to a machine from, say, 2015 or so, it could be incredibly limited, and every single thing that you change in your firmware settings becomes a UEFI variable. If you have a large DBX update, it can break your box. And we know this. The DBX design does not scale. If you, for example, Debian and 200 other Linux distros, each of them have 20 different grub binaries, all of which have seen problems and so need to be blacklisted, so they don't boot anymore because they're insecure, we've just broken half the world's computers. So the DBX design does not scale. SBAT, which I'm going to mention next, fixes this. We also get buggy firmware implementations. Like I mentioned, we have some systems that will not boot a dual-signed shim. Either that's because they've implemented a very old version of UEFI where it wasn't defined, or they've just added bugs. You know, buggy software. It does happen sometimes. We also have some reports of some systems that actually do check the CA expiry, even though they've been told not to. We also have some systems where they've randomly included some extra keys in firmware so that they will always boot some other software that you would never expect. There were a couple of vendors who included the Ubuntu root CA secure boot key, even though the Ubuntu people told them not to. It was a real mistake. Oh, and then, of course, we have randomly, some vendors have just leaked their secure boot keys because they were really bad at their own security. This is Security 101. If you're running a key-based architecture, don't give them to everybody else. So, SBAT is Secure Boot Advanced Targeting. That's a horrible term. I won't ask you to remember it. Instead of expecting that you have to store a hash or a key for every single thing you want to revoke, we have a generation-based revocations approach. I'll show you in a moment. It's much more efficient. The SBAT level, which is a variable in your system that you can interrogate, it will decide what is allowed to run or not. And then we embed data in the application binaries. I will show you that in a moment as well. So the SBAT level is included in Shim at build time. You can advance it further later, so if you decide that, if you've heard scary stories that this particular version of Grub that's out there is bad and is potentially buggy and might be a security hole, you can advance this further. We currently set that we must have Shim security level 4, Grub security level 5 is the default. So this means if you once you've put this onto your system, if you go and try and boot, for example, an old Buster installation image that didn't have a Grub, 5 security level included, with Secure Boot turned on, we will not let you boot that image because we know it's buggy. We know it is a security hole. Yes, that's a pain, but if you're going to have security updates, you can't just unroll them, or you can't go backwards to known insecure software. Microsoft have the same issue. Now, you probably can't read the text there. The slides are available online already. There are multiple lines here which can define which software is allowed to run. So this is an example from our current grub binaries in unstable and testing. The first line is the specification, SBAT version 1. The second line says that we are depending on grub, 5, which is the latest version of upstream patches for grub. We also have grub.debian, 5. That means that allows us later on to decide if I've screwed up in a grub upload, we can revoke older versions of Debian grub without everybody else having to do the same thing. We can also say grub.debian14, so if somebody screws up the forky version of grub, we can revoke those without having to revoke everybody else. Also, there's the PE image bit at the bottom here. That's a technical piece. It's a patch that we include in our grub that came from one of the canonical guys who's done a huge amount of work here. So if you want to bump things here, we bump the number or the SBAT level for an app each time there is a security event. So we've gone through several times places where people have done security checks against grub, have found holes, and we update. That's why we got to 2.5. If we go again, and we know that there will be, of course there will be more bugs, we just bump it to grub.6. That will revoke old, known insecure versions. If we want to just break the ones in Debian, to block the ones in Debian because we know there is an old hole, we can do that too as well. You can modify the settings on your own systems to do this too. It's deliberately designed that way. This is so much more efficient than DBX was, and it does work. So, sorry, I know I'm running quite close for time. I'm going to skim through these fairly fast. There's a lot of tools around UEFI and Secure Boot. We all know FLOSS tools, free and open source stuff can be great, but security tools are often not. Hands up here, anyone who likes using OpenSSL on the command line, for example. This is even more, it's almost the law that security tools have to be awful to use, and the fewer people that use it, the harder it gets. So there are not many people around who use any of these tools. So this is not me saying that the authors are rubbish or anything. The way that free software works is people file bugs, people tell you when things are broken, and you improve them. If you don't have many users, you don't get those bug reports. So some of these tools are quite sharp edges. We have EFI-var, which gives you low-level access to EFI variable space. The kernel exposes stuff under /sys. EFI-var lets you view and edit things. Do not get this wrong. If you're going to make changes, you can break the world. EFI Boot Manager is a friendlier version of that lets you tweak boot order and add new boot entries and so on. Mockutil is the way that you can find out everything you wanted to know about the EFI variables on your platform that relate to Secure Boot and Shim. You can list the contents of each of the key rings. You can check if Secure Boot is turned on or off. You can list the SBAT revocations. Remember the variable I mentioned earlier, SBAT level? That's this. You can import new keys into your mock key ring. You can turn on debug. Be aware if you do, it's very, very noisy. But if you want to debug a problem, it's there. SB Sign Tools is a suite of tools for managing signatures. We use this in the Shim signed packaging. PE Sign is another set of tools. The two are interacting on the same binaries, doing the same stuff. They are written by different people with very different ideas as to how these things should work. Have a look if you're interested. They may scare you. Future, quickly, what's coming? There will be more CA and key rollovers. We know that there are requirements on Shim, just like everybody else, to do post-quantum crypto. Do not be scared about this. It's coming. There will be more CAs. We know there will be more architectures. RISC-V support is coming in the next Shim release. I don't know who's going to be the CA, probably Microsoft, but the conversation hasn't happened yet that I know of. We've added more bug fixes, there's more hardening coming, NX has happened, and there will be more revocations because, of course, there will be. Software has bugs. And when we find those bugs, revocations are important. It's how we do things. I'm going to say questions, but I know we're out of time. We might squeeze one in if the video team don't stab me. If you want to know any more, there is a huge page in the wiki and loads more links from it talking all about Secure Boot. If you can't find me or can't find it there, shout at me and I'll update the page.
Okay, one quick question, please. Okay.
Anyone? Go.
So you mentioned that Microsoft refuses to sign anything that's under the GPL for some reason. I assume that's because of copyleft. It would apply to any other copyleft license.
Exactly that.
But why? Because they don't have to ship it, or it's not
well,
like...
specifically it's the GPL3 they're worried about. The GPL3 has language that talks about signatures and things. And if you have to be allowed to replace signatures. And they just saw it was easier. They don't want to get into the argument when people turn up and say, but you have to let me do my own thing. It was just easier.
Okay, thank you.
Okay.
Okay, unfortunately time is up, and let's thank our wonderful speaker and for his wonderful, excellent speech. Okay.